What's going on, everybody? Today we are finding the slope between 2 points. I like to use M&Ms when I do this as a visual because when we eventually plug in slope into the equation, we're going to use y equals mx plus b, and slope is that letter M right there. So I'm going to use the M&Ms as a visual here and get the idea of plugging in 0, 3 and seeing 0, 3 on a graph, and then going ahead and take 2, 8. And we can see that we have a positive slope that we should get in between our 2 points. Now you may have learned that slope is rise over run, and you would say, hey, the M&Ms are rising 1, 2, 3, 4, 5 over 2. And our slope is 5 over 2 using the idea of rise over run. Today I'm going to introduce you to something a little bit different as we head to our next problems, and you're going to see exactly why in just a problem or two. Cool, so I'm going to go ahead and take this next one. I got 0, 3, same thing, 0, 1, 2, 3, and then 2, 7, 2, 4, 6, and 7. And again, we have a positive slope that's happening, and here we can do the rise. 1, 2, 3, 4 is our rise over our run, which is 2, and 4 over 2. In this case, it simplifies. In the last case, it didn't. So a slope of 2 is telling me that each time that I go over one step, the slope is going to go up 2. And each time I go over one step, the slope is going to go up 2. So again, we have kind of, these weird connections as to rise over run that we're learning. We can see the visual. We get our slope calculating rise over run. Hopefully you see the issue here. I can plot 2, 3, but it's going to take me a while to count over 12 and up 43 spots, and I don't have a graph. I don't want to waste my time doing that. So we're going to learn a new definition for slope. Our new definition for slope, here's the shortcut, symbols. What that means is change in y over change in x. It's a Greek letter which stands for change. All right, that's called the delta, but change in y over change in x. We've got One Direction night changes going on. The last song was Thomas Rhett, life changes, right? That's all on purpose. Slope is our change in y over change in x. So real quick, if I said, hey, how much has your height changed since you were 5 till now? That would be a positive change, right? We're growing. So you would want to take your newest height, right? Maybe I'm, how tall would I be right now? 6 feet tall. So, maybe I'm like 72 inches now. That's my second height. And I would go ahead and I would subtract the height whenever I was 5 years old, however that might be. I don't know what it is. All right, so there's a positive change there. It's different if I took my original height when I was 5 years old or whatever, and I subtracted my height now. I am finding a change, but now I'm negative, and I haven't shrunk. So when we go to find our change in y and change in x, you want to take your second y value. So you'll see this in math textbooks often. y2 minus y1, x2 minus x1. What they're really telling you is they want you to take that second value, that newest value, and subtract the first one. But if you can just remember this right here, I think you'll be okay. There, how do you find your change in y? You just subtract them. How do you find your change in x? You just subtract them. But we are going to go ahead and take that second value, the newest value first, and then subtract the first value that we have there. Cool, so I'm going to go ahead and do this right now. I'm going to go ahead and take my 2 y values and I'm going to subtract them. But I'm going to go ahead and take that newer y value, that second y value. So if it helps, you can go ahead and label x and y. You can label x and y. I want the second y value, so I want the 43 minus the other y value, which is 3. So my change in y is going to be 40, and that makes sense. If I just erase this little arrow here, what actually happened is we went from 3 to 43, which is a positive change. It's a positive 40. So when we want to go calculate this, we want to take the newest value and go back and subtract the other value. Cool, so we're going to do the same thing with our x's. I can actually just go ahead and take this little thing right here and just loop it over to my x's. And I'm going to go ahead and subtract my x's, which in this case I have as 12. And I'm going to minus the 2. That's 10. I can go ahead and divide those and simplify, and I have my slope. So now I don't need a visual, now I don't need a graph. It helps sometimes, I'm definitely a visual learner, but if I don't have the graph or if the numbers are too big, that's gonna waste my time. That's where math and formulas help us out, right? So here's our shortcut, here's our formula. Cool, I can go ahead and plot these numbers, they're pretty easy. 1, 7, 1, 2, 3, 4, 5, 6, 7, and 6, 5, 2, 4, 6, 1, 2, 3, 4, 5. We can see that we have a negative slope here, right? We can see that we are going, we're going crazy over slope, right? We can see that we have a negative slope going on here. And what's happening is we're going down 2. So it's not really a rise. So that's why it's maybe better to look at it a little bit differently instead of just remembering that trick is rise over run. And then over here, it looks like it go over 1, 2, 3, 4, 5. Let's go ahead and as Taylor Swift comes on with one of her songs about change, let's go ahead and see if we can mathematically get negative 2 over 5, the same thing that we got as our visual here. Remember, it's change in y over change in x. I'm trying to get these songs all going with the idea of change, and we want to look at our y values first. Going from 7 to 5 should be going downwards, that should be going negative, but remember the way that we do that is we always take the newest value and then we subtract the other one. So we want y minus y over x minus x, and we like to take that second value to start off. So I'm going to go ahead and take 5 and then minus to the 7, which was the first value. That is a negative 2. Hey, didn't we have negative 2 as our rise on that graph right there? Not really a rise, actually a drop, right? And then we can go ahead and just slightly move this, boom, and 6 minus 1 would be what we're looking for with our x's. So we want to take our newest x, subtract the 1, 6 minus 1 is 5. Hey, didn't we say that we went down 2 and then over 1, 2, 3, 4, 5 spots to hit that other M&M? Cool, so we have proof that our formula is working for what we see visually. On this one, we don't even have a graph. We have some negatives. Maybe we're worried about plotting the negatives. No worries at all. We take y minus y over x minus x. Remember, this is your change in y over change in x. All right, take your newest y value, which is the negative 5. Subtract the other y value. That's your 7. So what's happening there? That is negative 12. Then we take our x of 3 minus 1. That's easy. That's 2. We can go ahead and simplify our slope or divide it to say that our slope is negative 6. Cool. I think we just got one more problem here. We got another negative, but this one is key. This one is key as to what happens with our formula when we subtract our y's and then we subtract our x's when we're finding out change in y over change in x. Watch what happens when you go ahead to take your y value. And again, if it helps you, go ahead and label x and y and x and y. Take your y value of 5, and then you go back and you subtract a negative 2. We subtract a negative 2. Let me go ahead and think about the problem real quick here. So we're going from negative 2 to 5. That is going from a negative number, negative 2, going all the way up to 5 to a positive number, right off the screen there, right? That is an increase, that's positive. I should definitely get a positive number when I do this. What happens with 5 minus negative 2? Ah, that turns into a 7. That is a change of 7. Slope is trying to figure out the change of 7. So how do I do that? I take my newest y value, I subtract back to the other one. Cool, for my x's, I'm going to take my newest x, which is a 3, and I'm going to subtract to 1. That gives me 2. My slope is 7 over 2. I don't have to simplify it, but that fraction doesn't. I could turn it into 3.5 if I really wanted. That is also equal to it, but I think we're okay with keeping it as a fraction. And there is our slope. Remember, it is change in y over change in x. How do you find the change? you subtract the two numbers. You want to keep in mind you want to start with your newest value and then subtract back to your original, your first value. So that is our y2 minus our y1. And then we take our x2 minus our x1. So hopefully that gives you lots of ways to think about slope, lots of ways to use the formula. We don't always need to have that visual, even if we are visual learners like myself. Now we got a formula that we can figure out any of these ways, and that's how we calculate slope between 2 points. Have a good one.